Welcome to aminacademy.com. In electrical engineering, let us discuss about electrical resistance. Resistance, it may be defined as the property of a substance due to which it opposes or restricts the flow of electricity, that is electron, through it. Consider a metals, acids, salt, and salt solutions are good conductors of electricity. Amongst pure metals like silver, copper, and aluminum are very good conductors because it have plenty of free electrons in outer shells of that atoms. These vagrant electrons assume a directed motion on the application of electric potential difference. These electrons, while flowing, pass through the molecules or the atoms of the conductor, collide and other atoms and electrons, thereby producing heat. Those substances which offer relatively greater difficulty or hindrance to the passage of these electrons are said to be relatively poor conductors of electricity, like bakelite, mica, glass, rubber, PVC, etc. Even dry wood also. Amongst good insulators can be included fibrous substances such as paper and cotton when dry, mineral oils free from acids and water, ceramics like hard porcelain and asbestos may, and many other plastics besides PVC. It is helpful to remember the electric friction is similar to the friction of mechanics. Here, suppose a electrical current passes through a different substances. Some substances allows easily the electricity pass through it. Some substances it won't allow easily. If it allow easily, it's called conductors. If have some resistance to move, the electrons move through the circuit, so it's called a resistance. Here we discussed metals are good conductors and non-metals like wood, plastic, rubber are having more resistive nature to pass the electricity. Now we'll discuss about the unit of electricity. Unit of resistance. Unit of resistance. Here the practical unit of resistance is ohm. Here unit of resistance is called ohm. The symbol is like. A conductor is said to have a resistance of 1 ohm if it permits 1 ampere current to flow through it when 1 volt is impressed across its terminal. Means 1 ohm is defined as a conductor is said to be having a resistance of 1 ohm if it permits 1 ampere current to flow through it when 1 volt of electric potential, 1 volt is impressed across its terminals. For insulators whose resistance is very high, as much bigger unit as used, that is mega ohm. Suppose, therefore you can say 1 mega ohm equal 10 to the power of 6 ohms. Very high resistance for non-conductors, that is insulators. And kilo ohm also there, 1 kilo ohm is 10 to the power of 3 ohm. Like very small units also there, it is milli ohm. 1 milli ohm is 10 to the power of -3 ohms, and micro ohm equal 10 to the power of -6 ohm, etc. A German scientist, Simon Ohm, first discussed about the resistance. So the unit of resistance resembles his names. Now we'll discuss about the law of resistance. The resistance R offered by a conductor or conductor is depend on the following factors. First one, it varies directly as length. Means if length of the conductor is more and more, the resistance also increase regarding the length. And it varies inversely as the cross section A of the conductor. Suppose thick conductor have less resistance than thin conductor. It depends on the nature of the material. Means some materials have less resistance, some materials have more resistance. For example, metals have very less resistance, as well non-metals like rubber, plastics, all having very high resistance. Next, it depends on the temperature of the conductor also. Now let us discuss this law of resistance. Consider the circular cross-sectional of wire. Here it have cross-section A and it have length L, and consider another conductor have less cross-section but more length. And also consider a cubic box of conductor, means conductor material. Here this having cross-sectional area, and suppose this is L. Now consider this first conductor have more thickness, that is a cross-sectional area is more, and less length. It have very less resistance because the electricity pass easily through it. Here the second one have less cross-sectional area and having more length, so it have more resistance. Now from the laws of resistance we discuss here, R, the resistance R is directly proportional to L and inversely proportional to the cross-sectional area, or we can say R is equal to some proportional constant rho into L by A. Here R is the resistance of the material, L is the length of the material, A is the cross-sectional. Here rho is called proportional constant and is called resistivity. Here rho equal resistivity of that material, resistivity. Now Now we'll discuss about units of resistivity. Units of resistivity. Here, from the above relation, we get rho equal Ra over L. R is ohm. The unit of R is ohm, and A is meter square over meter, and 1 meter square we can get ohm meter. So the resistivity of a substance is defined as, the unit is ohm meter, and we can get that relation ohm equal to Ra by L. We have done. Please subscribe our YouTube channel.